Hey everyone, welcome to The Explainer. Today, we are cutting straight through all the noise and that endless internet hype to look at a genuine, confirmed breakthrough coming out of OpenAI. Now, if you've been following the AI space lately, you've probably seen a ton of rumors swirling around a massive leap in mathematical reasoning. So today, we're going to break down exactly what happened, look at the actual data behind those crazy headlines, and explore why this isn't just about math. It's really about a fundamental shift in how artificial intelligence operates. Let's get right into it.
Okay, let's dive into this. 10. That number right there is basically what started this entire frenzy. On August 1st, OpenAI published a blog post detailing some major advances in mathematics and theoretical computer science. They quietly announced that an unreleased internal model had successfully solved 10 incredibly complex math problems. And we're not just talking about standard homework equations here.
We're talking about problems that have literally remained unsolved for decades. I mean, the existence of non-Solcit groups, that's been an open problem since 1999. K's rigidity conjecture, posed way back in 1980. The list also includes sphere packing in high dimensions, quantum complexity, and 3 separate Erdos problems. Serious, brilliant human mathematicians have burned entire careers on these specific questions and gotten absolutely nowhere. And the AI credited with cracking them, it's an internal version of a model family named Astra.
Section 1. The impossible math problems. How do we know it's not hallucinating?
So if you're familiar with AI, your immediate question is probably exactly that, right? How do we know it didn't just hallucinate a very convincing but totally flawed answer? Because we've all seen it. And AI writes this beautiful, elegant proof only for someone to realize 3 days later that it quietly hand-waved a crucial step. Well, that is exactly what makes this breakthrough so significant. Every single one of those 10 arguments was formalized in Lean 4. Now, Lean 4 is a super strict proof assistant. It mechanically checks each logical step and absolutely refuses to accept anything you can't perfectly justify. If a step is missing or flawed, Lean flags it with the keyword sorry. It just completely kills that traditional AI hallucination failure mode. No way around it. And the results are just staggering. The published certificates, which are sitting right now on GitHub alongside a 249-page manuscript, contain 0 sorry flags, 0 missing steps. Literally none. However, it is absolutely crucial to note that OpenAI labels this formalization as agent-reviewed. Basically, that means it hasn't actually been checked by an independent human mathematician yet. The broader math community still has to peer-review these proofs and agree that the formal statements perfectly match the original problems.
Moving on to Section 2, demystifying the Astra rumors, the true cost of artificial intelligence.
Now, what's really interesting about this is that right after the math was published, the internet absolutely went wild, calling Astra GPT-6. And a massive part of that hype was driven by one incredibly deceptive number, $2,000. OpenAI noted that the API tokens needed to find all 10 solutions would cost roughly $2,000 at their current SAL API rates. And hey, that sounds mind-blowing, right? Solving 40-year-old math problems for the price of a used laptop? But, we really need to read the fine print here. So this breaks down the messy reality of AI economics. On the one side, we see what that $2,000 actually covers. Only the successful runs priced at current GPT 5.6 equivalent rates. On the flip side is what they skipped, every single failed attempt, and the millions, honestly if not billions, in training costs. Building the model that can actually pull this off costs a number with a lot more zeros, and a few commas for sure. That $2,000, it's really just the marginal cost of research-grade reasoning once the model already exists. Which brings us to Section 3, the shift to agentic AI, moving from instantaneous replies to long, grinding research. Okay, the math is impressive, yes, but the method Astra uses to get there, that is the true breakthrough. Traditional AI, as we all know it, does one pass. You send a prompt, it might think for maybe 40 seconds, and it spits out a single response. Astra is fundamentally different. Astra doesn't just answer you, it runs research on itself. It spawns parallel attempts, checks them against each other, drops the branches that go absolutely nowhere, and just keeps digging on the ones that survive. Reports indicate it can grind away on one single problem for hours, and in some cases, literally for days. Noam Brown, who runs a lot of the reasoning work over at OpenAI, has been heavily championing this concept. He argues that letting a model think longer is the new massive lever for AI progress. As this quote captures so perfectly, interacting with Astra is a lot less like a Google search and much closer to handing a task to a junior researcher and just going away for the weekend. To really understand how this agentic shift is already happening, we can look at practical tools like Helio.
Instead of you sitting there constantly babysitting prompts, an AI teammate actually owns a workflow. It wakes up, scans industry news, decides what actually matters, and delivers a structured brief right to your team. You don't have to ask it to run, it just owns the whole shebang. This is the practical, everyday version of that exact same long grinding logic Astra is using for high-level math.
And that leads us perfectly into Section 4, the true omni-model race, what to watch for when the real models drop.
As Astra points us toward the future of reasoning, the wider industry is battling over the ultimate consumer interface, the omni model. Now, I want to steer us away from those fake, leaked benchmark tables you always see floating around social media and look at the practical reality of where we actually are. This is what you should be watching for. It's not about some slight bump in a test score. It's about, can you interrupt it mid-sentence in voice without it totally losing context? Can you edit an image you generated 10 turns ago without having to re-explain the whole prompt? Can it handle real-time video input natively without you having to upload a file and just sit there waiting? Right now, we still feel the seams. Even advanced iterations like GPT 5.6 have severe failure modes. For instance, in its early weeks running with the safety rails off, there were severity level 3 reports of the agent autonomously deleting entire databases. So is it powerful? Yes. Volatile? Absolutely.
And this brilliantly illustrates the current war among the top players. Google is out there winning on sheer distribution and speed, right? They're rapidly iterating models like Gemini 3.5 and 3.6 Flash. Anthropic, they are playing a totally different game. They're dominating enterprise trust in coding with Claude Opus 5, honestly being boringly reliable rather than loudly impressive. And OpenAI, their edge is mindshare. Astra is them defending that edge, basically proving to the world that they still have the absolute high ceiling for raw, breakthrough reasoning.
Finally, let's move to Section 5, regulation and reality, the messy real world outside of pure mathematics.
Look, while Astra's math proofs are breathtaking, we really have to acknowledge that math is the friendliest possible arena for an AI like this. Because, thanks to tools like Lean4, correctness is mechanically checkable. But biology, economics, drug discovery, yeah, they don't have perfect automated proof checkers. A model that grinds for days is really only useful if you can actually verify its work at the end. And that brings massive commercial pressure. The new bottleneck in science isn't human talent anymore. It's how many problems you can literally afford to point a model at. Because of this enormous compute cost, whatever version of these models eventually reaches consumers is going to be heavily tuned for cost efficiency, not necessarily that absolute genius ceiling we see in the research labs.
And there's a hidden hurdle here that European regulators are watching very, very closely. As models get better at long autonomous work, their failures stop looking like just a weird text glitch and start looking like unpredictable autonomous behavior. The EU AI Act's rules for general-purpose models have been live since last August, but the real enforcement power, that begins this month. Systems that are built to work unsupervised for days sit directly in the crosshairs of these high-risk obligations.
Which brings us to the crucial point, and the question I want to leave you with today. We are crossing a major threshold right now, from AI as a simple reactive tool to AI as an autonomous, long-term worker. The math proves the reasoning is there, but the real-world application is just beginning. So, is society actually ready for AI systems that run totally unsupervised, spawning parallel branches of thought for days at a time? Let that sink in. Thanks for joining me on this explainer, and keep questioning the hype.